Assalamu alaikum, welcome everybody to Practical Numerical Methods for Scientists and Engineers. We are still in Module 3 and we will study new method, opening method, secant method. If you remember, we in last tutorial we discussed Newton-Raphson method, and it used derivative function to find the new solution or a new estimate of the root. Sometimes there's difficult to make derivation for function. Some function can't be derived. Hence, Newton-Raphson can't help in this, but new methods now is secant method can help in this. So, in secant method, it used the back forward finite derivative divided difference between 2 x instead of derivative itself. Okay, so as you know, it means it uses the slope. Okay, so it requires here two approximations, x naught and x1. So this is the old, and this is one, and after one, and then later it will be used the old one. So, and connecting the line between the x1 f and its function, and x2 and its function. Okay, that will cut the x to produce x1. Okay, so if you have this function and you have two estimates, two guess, okay, two guess, this one and this one, so this line, this point will be the new x. Okay, so by repeating this step, the approximate become closer and closer. Let's discuss it in a more closer way. So now you know this is the function. This is the function. Okay. Let's clear it. Okay. So now we have this point is fx. This is the initial guess, and this is the second guess. Okay, and there are post given. So also they are not necessary to have them bracketing, because it's open method. Secant is open method, so no need to have them bracketing. So this is x naught fx, and this x1 fx. Okay, so if we connected the line between them, okay, this line will cut in x3. Okay, so x3 will be the new point. Then x3, this is a function of x3. Let's make it I want to make it larger, so sorry. Okay, let's do it again. So now we said we have, this is the initial x and this is the second x. Okay, and this x has a function here on fx, and this x has a function here on fx1. So we can then extend the line, and this line will produce xl, and then x3, and then from x3 we can find f of x3, and this will cut here. Okay, this will cut here. Then x3 and x1, okay, becomes a new point, so we can extend the line between them, okay, and find this line will cut to find new x4 very closer, and so on. Okay, so now the slope, the slope here is f of x minus f of previous x over xi minus x previous x, x minus 1 this previous x. Okay, so now you know that in the Newton-Raphson method we said x I minus 1, the new solution will be xi minus f of x over f, the derivative f dash xi. Now I can substitute this one to put it here. Okay, so this will produce new equation, and by rearranging I can get the new estimate. Okay, so this one I don't have any derivative. Okay, so it will be good for equations difficult to be derivated. Okay, so now since we have a clear picture, now we can create our method. So we have input, initial guess of x naught and xi, x1. We have to put the f of x. Then we have also to put the relative error and number of iteration, and the output will be improved estimate or for real messages iteration. So first we set equation 0 to f of x0 and equation 1 to f of x1. Okay, and then we start from I equal 1, this iteration, to do these steps, and then we can find the relative error. Okay, so and if the relative error is less than that assigned here, so then stop. Okay, then we can x naught will consider it as x1, and x and the equation 0 will be equation 1, and then x1 will be x and qx. Okay, now let's see how to make it on MATLAB. Okay, now we'll start with input. So we have input, if input, insert the equation, and then insert the estimated root 1 and insert the estimated root 2. Okay, after that we have the relative error input, relative error as input. So put the relative error, and here put the maximum iteration. Now let's start our iteration. So I equal 1, while I less than iteration, then x equal x1, okay, this one, minus f of x1. So we just apply this equation, okay, times x1 minus x naught overall f of x1 minus f of x naught. So here we define the each of them. Okay, then find the relative equal apps x minus x1 over x. Then that, so as we said last time, this is used to record. You can cancel this one if you don't want to record, but it's good to see how you you already did your iteration. Okay, so and then if relative less than our relative, see we here just we put here the relative, so it's case sensitive as we said before. So and we defined here new error relative. Okay, then break in. Otherwise I equal I minus 1 to continue the iteration, and x naught will be x1, okay, and x1 will be x, because he will take the x1 x naught, so x naught becomes the x1, and then x1 will be the x. Okay, after that record that. Okay, so that will put all the table or the record, and if print if the as we exactly did last time. So this is will be the secant method codes. Okay, and this will be our solution. I think it's easy, yeah, and you can perform it by yourself. Okay, so this is all about secant method. See you in another module. Thank you.